Hi everyone! Today I'm going to show you how to use Einblick to cleanse data, make visualizations, and build a predictive model. The data set that I start with is of patients. Some of the patients have cancer, about 8% of them, which I can see by dragging this column out and making a histogram. And as well, I have about 60 columns from their physical, which is height, weight, their race, gender, as well as a number of blood panel characteristics like CO2. You can see some things like platelets, neutrophils, and then also things like bilirubin, etc. This is a demo data set, obviously no real patient data here, but what we're going to try and do is predict who has cancer, find which characteristics predict that, and hopefully build a predictive model that would help a physician diagnose future patients from their blood panel. The first thing that I notice is that there's some of these columns that seem to have unknown values. For instance, height. It seems like a significant number of the rows in height actually have -1. And to explore that, all I have to do is drag height onto the canvas, and I immediately see that about 50% of rows don't have a height column available to me. There's obviously a number of different treatments I can do here, but to kind of further explore all the columns, I can go ahead and make a Python cell. And the first thing I'll do is to take my data set, which is called blood panel predictive CSV, and I'll use the describe function in Python, and we can see that for age, there's some age of less than 0. That doesn't quite make sense. There's age up to 200. Also doesn't quite make sense. We have height, weight of -1 for a significant number of rows. And we would ordinarily spend a little bit more time here, but for the moment, I'm going to just progress with removing some of these -1s and treat them as nulls. The other thing I noticed is that I have some categorical variables. To work with these in a predictive model and also to kind of get correlations, I need to turn these into dummy variables. I'm now going to use Einblick prompt to pre-process my data and turn the categorical variables into numeric columns, and also to remove the outliers and unknown values. Einblick prompt is a way to use natural language or simple English to get to the results I want. For instance, here I'm going to say for text columns of race, sex, and marital, turn them into dummy variables. Writing code as human beings is fraught with danger. We typically forget a comma and we don't have all the syntax memorized. Instead, what we have here is an AI assistant which helps me write this code. And if I execute this code, I can see that my new table has columns in it, such as marital unknown, marital widow, marital single, marital separated, etc. And I see that I've successfully turned those categorical variables into binary columns. I can also now at this point run a little bit of code to remove the unknowns. So for instance, I might go and ask for a new step, remove all rows from df columns with a value of less than 0. And for this one, I'm going to say df blood panel predictive CSV in particular, because even though it's an AI assistant, I have different data frames, and by giving this hint, I'm able to help provide context to it. I'm going to go ahead and execute this step. We can continue to make a quick preview, and I can see that now the number of rows has gone down from 30K to just 10K, but at the very least, I have heights of greater than 0 only, no -1s. Next, I'm able to go ahead and get some correlations. I'm going to ask for getting correlations with cancer in this data frame. And you can see the thought process as it goes. It has provided this to me in a JSON format. Maybe I don't want this in a JSON format. And I say, don't return this in JSON format. And it will go ahead and edit this code and actually give it back to me in hopefully a normal way. Here, it forgot to subset, and instead I can get this. And, there's 77 rows, so truncation happens in the console. I'm probably going to try and make a chart off this next. But first, let me make a quick variable called core, where I subset correlation matrix for just the cancer variable. Then I'm going to go ahead and add a new cell and say make a vertical bar chart from array correlation with the index as labels. I go ahead and hit run here, and I see that there's a somewhat messy chart. Here I can ask for it to edit my chart as well. I can ask for it to reduce the font size and sort from lowest to highest value in core. And when I run this again, I can see that it's sorted. The font maybe is still a little bit too big, but I can go ahead and change that manually to 6, and I get a chart that makes some sense. And I see that the top correlations are HCT and lymphocytes, eosinophils, and the lowest correlation is maybe some of this height and weight. I can go ahead and actually manually add code as well. For instance, I can go ahead and make the figure a little bit wider and make it easier to read. I also maybe just want to see the correlations in general all the way back here with all the variables together. Here, I can go back here and say add a new cell and say show me the correlations as a heat map. Here I run this and I can see it forgot to import the package, so I help it out a little bit and then I hit run. This is a little bit hard to read because I have so many correlation values. It's using the Seaborn package, which is not perfect for this use case. I can always ask it to edit this, but I'm actually going to say this is a mess. I'm going to change the cell and say use plotly instead. And one of the key things to note about Einblick prompt is that knowing the packages that I have available to me and what I can do allows me to kind of make this change relatively easily. And I can kind of get to this heat map. And so make the plotly chart dimensions big. Now I get a bigger result. I still don't have all the columns, but I can see the cancer values and I can kind of see some of these higher correlations over here. Some of these variables seem to relate to each other. Some of these variables seem to anti-relate. I'm not exploring that now, but this now exists. Swinging back to the other chart here, what I can see is that HCT, lymphocytes, EOS, eosinophils have the highest correlation with this cancer variable. I'm going to go ahead and make some charts of cancer versus these variables. Now I can ask prompt to make these charts for me, but actually let's go back to the Einblick no-code charting capabilities. I can go ahead and drag cancer out here, and all I have to do is change the x-axis to maybe EOS, and I say equal with binning, and the y-axis I'm going to set to average value, and I can color it in by the number of rows and change the color scheme to more rows is more red. I can see that the higher values tend to predict it, but most people have fairly low values. To make another chart, all I have to do is to right-click duplicate, and I'll get another chart, and I can go to the x-axis again and say change this column to maybe albumin, and I see that there's some anti-correlation, but the vast majority of values are over here. We can zoom out at this point, put a little bit of a zone around this early exploration, move this over to the side, and start again with another exercise in making a predictive model. In order to make a predictive model, once again, we can always ask prompt to build a predictive model to predict cancer. But at the same time, we actually created a package for you which wraps up many sklearn, tpot, and Shapley functionality. So all you have to do is specify the data frame. Here it's blood panel predictive CSV. Specify the target column, the type, classification or regression, and your accuracy metric. Here we're going to use F1 score. Hit say preprocess, say train, and off it goes, and it will automatically do a lot of pre-processing steps for you. Obviously, the AI assistant, very helpful to write code for you, but at the same time, the AI assistant isn't always better than picking the right package. So here we install a bunch of packages and the model training begins. We gave it about a minute of time, so we're going to fast forward. And we see that the model score comes back with F1 score of 0.533, which is pretty good. If we want to see the results and kind of see what we got here, we can use the ml.explain, run this, and we'll generate a Shapley explainer. And we see red blood cell, neutrophils, blood, and HCT hemocrit are the top drivers of this prediction. We can also get the prediction itself, even though I don't have another data frame right now. And we can use the apply model function, and we can apply it back to the original data set, which is blood panel predictive CSV, and get the head of this, or I can put this in a table and say df2, and I can see the new column is cancer. Maybe first I'll say df2 is equal to this one, and I'll say df2 actual cancer is equal to cancer. And then once I run this, I'll now have an extra column here of actual cancer and cancer. And I can make a quick illustration of here. And I can do a confusion matrix where actual cancer and if I normalize the y-axis, this is a somewhat of a confusion matrix. Zooming back out again, at this point I would probably go and draw another zone around this area, and I can now move this stuff over. Maybe I would change the color, and I could probably at this point share it with my colleague for him to join me live in the workspace or to join separately.